All right, welcome to the first recording of notes, which may be the second looking one, but this is the first one I'm making, so we'll see how this goes. Distance and displacement, something you'll never worry about outside of your physics class. We know it, so we take our time with it. All right, some definitions here. Scalar is anything that has a magnitude. And a magnitude just means it has a number to it. Tells you how large or how small something is. All right, so it has a magnitude. It has a number, but it has no direction. Things like 12 inches, 3 pounds, 45 meters, 5 years. Those are magnitudes, the 12, the 3, the 45. The units tell you what it is you're measuring it in. Vectors have a magnitude, so it has a number, but it also includes a direction, so it gives you more information. It's more specific. It's not just 12 inches, it's 12 inches directed up. It's 45 meters directed to the right. It's 300 miles north-northwest. So with the direction, we have more information. So a vector has more information than just a simple number. And so from Despicable Me, you have the first villain, which was vector, and he talks about how it's better because it has magnitude and a direction. So, all right, displacement. Displacement is distance from a reference point, and it will include a direction. And because of that, it is a vector. Okay, so what does this mean? Okay, this means that if my dot here is my reference point, and I take a trip and I go right for 20 steps, and then I go up for 10 steps, and then I go right, I guess that's kind of hard to see that one. See, so that's 10. And then I go back down left, let's say this way, for 30 steps. And then I come back over here. That's not a very good example. Let's do one we can actually do the math on. What am I thinking? All right. If we go right for 20 steps, and then we come back left for 30 steps, all right. For distance, we would simply add them all up. You just add them up. For displacement, it's where are you at the end, where is your x based on where you started. And to get there, we go from where we start, we draw an arrow, so our direction is going to be, we're displaced to the left. Anything to the right is a positive number, so we'd say positive 20. Anything going left is negative, so we'd be plus a negative 30. So we'd say that we ended up with negative 10. We don't want an answer as a negative, so what we're going to do is we're going to change it to a positive and put a direction. So our displacement is based on our reference point, our beginning point in this instance. So our displacement is going to be 10 steps to the left. So distance is what you and I would talk about every day. We drive 5 miles to the store, we drive 5 miles home, we put 10 miles on our car. Displacement is if I start at my home, I go away, but I come back to my home, my displacement means I ended up exactly where I started. My displacement would be 0. So again, we know it's only something that we care about in this class, so we will work with you with it. All right, so some examples. I move to the right 5 steps, and then I take 2 steps left. Okay, so we show it here, dot for our beginning. 1, 2, 3, 4, 5 steps right, and then 2 steps back. Okay, distance, add them up, so that it's 5 plus 2 gives you 7 steps. Displacement.
Good morning.
All right, so for displacement, Displacement, we're going to do positives and negatives because we're just going straight line stuff here. So to the right is positive, so we're going to say a positive 5. And we're going to add that to a negative 2 because we're going 2 steps left. Positive 5 plus a negative 2 gives me 3 steps. It's in the positive direction, so we're going to write it out as right. We're not going to leave it positive or negative. We're going to write the direction itself. And then down here in your notes, we've got the displacement will have a positive and negative based on the direction of the movement. If you're moving up or moving right, so this is similar to graphs. And then negative is down or left. The triangle means change in, and as we progress in this, we'll see a triangle for the x-axis. If we're moving left and right, then any change in where we start and where we end up along the x-axis will be called delta x, or change in x. And if it's in the y direction, up and down, if we're at the top floor and we fall all the way down to the ground, that change would be the change in y. Since we're going down, it would be a negative. So that's why we have positives and negatives. All right, now, not everything will be left and right. Some things we will have an angle. So if we have an angle, we're going to use the Pythagorean theorem. The Pythagorean theorem is c squared equals a squared plus b squared. Now, so let's say a woman runs east. So we have to know our points on the compass. So north is the top of the page, east is to the right of the page, south is the bottom of the page, and west is the left of the page. So as you go clockwise, starting at the 12 o'clock position with north, it says north, never eat sour watermelon. As you go around, never eat sour watermelon. All right, we're not going to care about the time here. That was for a different worksheet. So a woman runs east. That's going to be to the right, so we're going to draw an arrow to the right. We're going to label it 1,700 meters. And then she's going to turn north and go 700 meters north. And what we want to do, scratch out the word velocity. Again, this originally went with a different worksheet, and I forgot to make that change. We're going to solve for distance and displacement on all these. All right, so distance. Remember, distance, we simply add them up. Okay, so to do that, it's 1,700 plus 700, and that equals 2,400 meters. Now, because we have an angle right here, we can't just do positives and negatives, because what we're going to do is we have our start position where my dot is, we're going to end where my x is, and so the direction and the actual displacement from my reference position is going to be my hyphenated line here. So to do that, we're going to use the Pythagorean theorem. We're going to say c equals the square root of a squared plus b squared. Now, it doesn't matter if you label the 1,700 your A and the 700 your B, or if you label 700 your A and 1,700 your B. Just put it in your calculator, square root 1,700 squared plus 700 squared. And then when you solve for that, you will get 1838.47. We're not going to care about the decimals. Our unit is the meter, and then this direction, all we do is we're going to put our two directions, east and north. North and south usually go first, then you have east and west. So that would be north, east as our example. All right, so all of this stuff is going to be straight line backwards and forwards, or we're going to have an angle, and then we'll show one that has a little bit different. All right, we're not going to do this example because that's what we just did. So number 2, you take your dog out and you let him run. He runs 30 meters to the right, so we're going to draw an arrow and label it 30 meters to the right. Then you call him and he runs at you for 20, and then he runs away for 40. So the distances, remember, you just add them up. So I'm having my students write add when they see distance. And that means it's 40 plus 20 plus 30. And that gives you 90. Now for displacement, we've got positives and negatives. To the right is positive, so positive 30, we have a negative 20, and we have a positive 40. So positive 30 minus 20 gives me 10, plus 40, that gives me 50 meters, and my direction is positive to the right. So I'm just going to write 50 meters right. Again, we're not going to put positives and negatives in our answer. We're going to make all of our answers positive and put the direction that we're going. Okay, a running back heads 15 meters to the right, sees a defensive end, goes back left for 5, then sees a linebacker and heads back right for 2 and falls down. Okay, so we have right for 15, we have left for 5, we have back right for 2. Distance, add them up. 15 plus 5 plus 2. That is 22 meters. No directions. Displacement, positives and negatives. Positive 15 plus a negative 5 plus a positive 2. So that is 12 meters right. Okay, now, all right, now this is, I made this up. I think this gets a little complicated, so let me show you what I mean as we draw it. If we did this from on the very top of the gym looking down as the ball is served, we have someone who hits the ball from right to left for 22 meters. And obviously if you know volleyball, then 22 meters is way too long. That's 67, 68 yards. So, I mean, 67 feet, that's 22 yards. That's too big, too much. All right, then it's going to be hit south for 4 meters, then played back to the east, which is to our right, for 2 meters, where it slams straight forward down the line for 3 meters. Okay, so that's how it's supposed to look, and I was trying to include the women's game, and since volleyball is the first game we have, I tried to make it volleyball, and it's hard to do. All right, distance, doesn't matter, we add them up. 22 plus 4 plus 2 plus 3. All right, so you add that up, you get 26, 27, 28, 31. And then with displacement, we have two things going on. We have the 22 meters going to the left. We have the 2 and the 3 meters coming back to the right. We can't use the Pythagorean theorem when we have two different angles. What we're going to do is we're going to take the 22 to the left and subtract the 2 and the 3 to the right to give me, and that will give me 17 to the left and 4 down.
Jeremiah Muniz, report to the counting office. Jeremiah Muniz.
And that allows me to use C equals the square root of 17 squared plus 4 squared. And my answer will be 17.46 meters. And that direction is going to be southwest. All right, that's how you do distance and displacement.